Your machines, sensors, and devices in industrial IoT generate endless streams of data, and the potential is massive. But certain critical use cases you need to make decisions in real time or risk missing the moment. So let's ask the key questions: which use cases truly demand real-time in action? Which technologies can handle this scale and this speed? And why does everybody suddenly talk about Apache Flink? And what should you be aware of when implementing this in your own projects? In this episode, we'll get straight to the point with real-world examples and insights that go beyond the buzzwords. I'm joined by Ben Gamble. He is Field CTO at Ververica, creators of Apache Flink, and Stephan Schiffner. He is CTO at Steadforce, expert in setting up industrial Kafka and Flink use cases for customers and partners. Today, we'll explore why so many projects get stuck and how to avoid the same traps, what it really takes to act on data in real time, and how to get started without over-engineering your architecture. Let's dive in, and full details you'll get on IoTUseCase.com. Let's go. Hi, Stephan, and hi, Ben. It's nice to have you on the podcast today. So how are you? Ben, I will start with you.
It's actually a wonderful day today. It's been a surprising heat wave in the UK. So suddenly the weather is good, and it's been a kind of busy few weeks of conferences as conference season kind of goes into full swing.
Yeah, I can imagine. And by the way, where are you exactly, regional?
As with most of Ververica, we work around the world. I'm currently based in the UK near Cambridge. My team is spread out between Athens, Oregon, and London right now.
I see. So yeah, nice to have you today. Stephan, how are you and how's your day going?
Yeah, thanks, Madeleine. It's a pleasure to be back again here. I'm based in Munich. It's a bit cloudy outside, so obviously not so nice as in London today. And I'm busy with a lot of meetings and stuff going on.
Right. So I appreciate your time, and I'm really looking forward for this session. And maybe, Ben, to start right away. So Ververica is known as as I mentioned, the original creator of Apache Flink. Can you explain the founding story behind and how the company and mission evolved over time? I would love to learn more about that.
Okay. So Ververica came about originally in Berlin from the Technical University. There was a project called the Stratosphere Project, which was designed around the simple idea that data was getting bigger. If you remember the kind of big data boom that kind of came out of the kind of early 2000s, late 90s, and big technology things that went with it were such things as the Hadoop era, basically, kind of characterized this. Now, the Stratosphere Project kind of as the foundation of the idea of bigger than memory, bigger than machine compute. How do you act upon all this data we've now gathered? And that rapidly became a project which was then donated to the Apache Foundation as something called Flink. Play on words because it was quick. And at least as I've learned recently, Flink is a German word for a cheeky kind of quick.
Oh, I see.
So, yeah. And Ververica means squirrel. And the logo for Apache Flink is a squirrel. And the squirrel comes from being the messenger on the Norse world tree, which carried messages quickly between the different realms. And Apache Flink slowly became the de facto real-time stream processing engine. It came out of the idea that batches and streams were not two different things, but really one. And anytime you process data larger than cache, then larger than memory, then larger than disk, you would always end up streaming your data anyway. So nearly all modern databases stream. Hell, if you go to the DuckDB main website, it says streaming quite clearly on it. Yeah. But Flink came from this idea that streaming was the more important thing to do, even if you were doing a batch. Mm-hmm. And then it kind of spread from there. It's sort of been the kind of behind the scenes for a while, and we had the 10th anniversary last year in Berlin at Flink Forward.
Congrats.
And it's sort of become that overnight success, 10 years in the making, as they sometimes say, where it's been powering the largest digital companies in the world, from your Ubers to your Amazons to your Walmarts, for many, many years, except now, particularly with people like us providing it, it's suddenly become mainstream, as the need for this kind of real-time has come down the stack from the largest and biggest to pretty much everybody. Because tell me the last time a customer asked something to be slower. Yeah. And I can't tell you when they did.
Right. And especially when we talk about IoT data and real-time use cases. So it's like a critical thing. And I would love to learn more about also your best practices, how to set up these projects, and then also talk a bit more about this in a second. Stephan, to give a very short introduction also to Steadforce. I know you guys pretty long. You mentioned you're in Munich, but can you give us a quick overview for those who don't know Steadforce, what you're doing and how does Steadforce apply streaming technologies like Flink and Kafka in industrial use cases? And by the way, about Kafka, we will talk in a second.
Yeah, so Steadforce is a tech company. We are building digital solutions for our customers now for 40 years. So we have our 40th anniversary this year. We are mainly focusing on 3 technical key areas, I would say. So everything around cloud solutions, that includes also migrating systems and modernizing applications. Then second, platform engineering. And third, and this is where it comes to Ververica, Flink and all that stuff, everything about data and AI solutions. Mm-hmm. And also we are working with leading companies from the automotive sectors, manufacturing, chemicals and medical devices, which I would say are our 4 core sectors.
Yeah, okay, nice. I was wondering, what's the difference between Flink and then we have Apache Kafka also? Because I put them too in this streaming area. So I would love to shortly classify Apache Flink a bit as a technology. Ben, can we talk a bit about where to put Apache Flink as a technology? And maybe you have one practical example to explain it a bit.
Actually, yes. The advantage of having given a talk on some of this very recently is I have this very close to mind.
Nice.
So if we kind of roll back to when Flink was created, Flink actually appeared at a very similar time to Apache Spark, which was technology behind the company Databricks, which everyone has pretty much heard of these days, which came out of the same idea that data processing was the challenge. Apache Kafka came out of LinkedIn a little bit earlier, but was born out of the idea that storing streaming data was the challenge. Apache Kafka is a storage engine for data. It doesn't care what you put in it, and it was optimized for writing vast quantities of data to a place that you could read it from almost any location. Even the name Kafka was kind of chosen because it was optimized for writing data. And what Kafka gives you is a durable distributed log. It's an append-only data structure where you can keep adding to it without really any concern of throughput, guarantee the data will survive pretty much almost any outage if you set it up right, and then allow it to be distributed via a kind of publish and subscribe model to almost any number of readers. It's a very, very powerful primitive in distributed computing, particularly when you have a combination of things like microservices or need to do big data distribution amongst other data systems. Flink plays very nicely with Kafka, but there is no dependency at all. It's simply a very nice pairing. Most often, a lot of IoT data specifically ends up in Kafka because of the nature is IoT data appears when it appears. And then when you're reading it, there's a need to just have somewhere convenient to read it from. So Kafka fits very strongly with the IoT side of what Flink does, though outside of that, it's more a very convenient pairing more than a dependency.
I see. So do you have one example of your, I don't know if we could name customers. I don't think so, because I guess a lot of OT experts also are listening up.
Sure. So I can name the customer and I can talk about a use case, but in this case, they are separate. But we work quite heavily with companies like Toyota and BMW when it comes to their kind of factories. Now, inside a factory, this is non-specific to the use case. A classic example would be, I have pieces being made. Most modern factories are effectively supply chains in of themselves. So you'll have, let's say, one line making the doors, one line making the wheel assemblies, one line making the brakes. And as these sub-assemblies come together, they need to be timed adequately. You can't keep making cars if you're low on wheels. You can't keep making wheels if you're low on tires, and you can't keep making hubs if you're low on bolts. Right. Managing all these various kind of rates of manufacture is critical these days to reduce what's known as work in progress. Work in progress is one of the big theories of constraint when it comes to making things in modern factories. You don't want to have spare stuff lying around because it takes up space, and particularly certain types of manufacturing pieces are actually quite perishable. Like rubber in its raw form is rather unstable. You don't want bolts to rust before you put them in, and you don't want your oil to sit around and get spilled. So these things you only want to have them when you need them. You don't want an oversupply clogging up your warehouse. You do not want an undersupply slowing you down. So monitoring all these things in real time and knowing when to order more, when to slow down an upstream process, when to speed up a downstream process requires real-time data. And a lot of what we do with manufacturing clients is doing more than monitoring in real time, but then acting on that monitoring.
Okay, cool. Do you have also another example where it's necessary to act on real-time data? Because I guess there are a lot of, also from the OT, like edge computing and technologies like this is known where you could really process high-frequent data on the edge. But in this case, you're doing it in the cloud. So why do you need to do it in the cloud? Can you explain that a bit?
Let's take the most common thing. So yesterday I was in London, and these days in London, there's increasingly no cash actually allowed at various payment locations. So there are cashless stores everywhere. The transportation network is all done by a credit card tap. So if I tap my credit card on the gates to a train platform, I need that to be processed immediately. So the gate opens in front of me and I don't cause a jam. But then if I tap to pay, that needs to go to the cloud, because the first thing they've got to do is verify that A, I can afford what I just tried to buy, B, I'm definitely me, and C, that the shop is indeed the person they think they are. Because let's say I tap a payment and it gets routed weirdly into, let's say, the MasterCard network, the Visa network, or the Amex network. They need to verify who actually tapped that. They need to work out that although I'm normally in London, suddenly this tap happened in Cape Town. So that might be a problem, particularly as the previous tap happened in Lagos. These things could be a problem. And that mandates the ability to have a real-time action taken somewhere, and nearly always in the cloud.
I see. We have some examples in the industry. Just wondering if that's also the case when you have the detection of, for example, of unusual patterns, like any current peaks or something where you really have to act on real-time data. Do you see similar use cases also in the industry here?
One thing, of course, could be anomaly detection. So let's say you have sensor readings, an example, temperature. Then you could see if at a certain point in time, the degree of the temperature hits a threshold or goes over a threshold. But I think what's important here, it's not only monitoring and identifying these conditions, but to get real value out of it, it should be a stateful analysis over the stream of data, because maybe it's interesting not that just that one peak, but did the temperature change its average over the last 5 minutes, for example? To come back to your credit card example, Ben, if someone pays with your credit card, let's say here in Munich, this itself is not a problem because you could be here on holidays. But I have to see in a time period of, let's say, 5 minutes, the same happens in London, then we have a problem. And then that means the context and the state around the whole processing is very important.
To elaborate on this exact thing of stateful compute is what the kind of key thing Apache Flink brings to IoT. It has always been relatively straightforward to just listen to a sensor. It's commonplace. You can have an alert triggers when something goes. Let's say you're manufacturing circuit boards. I've worked in this field before, and you have a wave solder machine. So it has this crest of molten metal, which the boards go past as they get soldered together. That wave has to be at a specific height and a specific temperature. If it goes too low, it won't do the boards, and you'll waste a lot of money. If it goes too high, you might damage components. So it's very easy just to have a trigger that says above or below. But if it's starting to trend down over time, over the last few minutes, you might be losing solder somewhere in your system, which means you might have a systemic fault, and just topping it up once will not be good enough. And this is where you need to do more than just recognize an event. It's recognize a pattern and have the ability to have the context of that pattern of, every day we have to top this thing up at 3 p.m. Obviously, there's a leak, which means we're losing this many milliliters per hour. Therefore, maybe we should now try and change it, fix it, or actually, it's okay. We'll just top it up at 3 p.m. every day.
Yeah, I see. Okay. So to talk a bit about also the problem statement behind, because I understood now why is that necessary and what kind of use cases there are. So why do you think many companies struggle to move traditional data architectures to real-time data processing? Because you're mentioning, Toyota, BMW, all these big companies, but you also have smaller companies who want to do that. But why do you think it is that many companies struggle with that?
So I think one point is, of course, that the existing infrastructure is grown and you have a lot of, let's say, legacy systems, or at least systems which are static, and you don't get the events out of these systems very easily. Flink has a good solution here with the Flink CDC sub-project. So you can really connect these legacy systems and then transfer it wherever you need the data. So it's really this extract, pre-process the data and move it. And I think the second point is that, of course, the data is not in that quality that you needed for a specific use case. So even if you have a good quality in your data, it doesn't be necessarily good for the use case you want to achieve. This is something you have to deal with before you go to Flink and do the processing.
Mm-hmm.
So to elaborate on exactly this thing, the curse of legacy software is that legacy software, if you're being really serious, is software which is making too much money to be safely deleted. The problem is that most of these companies have been around for a while. Manufacturing and most IoT setups take a while to come into place. Therefore, a combination between sensors themselves might not return in real time. Then the linkages between them and where it's stored have been built over many years and are probably doing a good job today. They could be doing better, which is where we come in. But if it's already working, you cannot rip it out safely, particularly on a 24/7 production line that doesn't turn off.
Mm-hmm.
Now, even if you go even to the more traffic type sensors, even those things aren't allowed to turn off. If you suddenly turn off the system that controls the traffic lights for a city, you might have a problem. And I've seen this kind of thing happen, particularly with ticket buying systems for national rail systems. And to go on to the next piece, I'm going to elaborate one step further there, is change data capture. The ability to pull streams out of existing systems is the right way to kind of advance things. There's a term which Stephan and I have used a fair number of times together now, which is evolution, not revolution, right? Mm-hmm. Because if someone's come to us saying, hey, we need to go real time, the answer is, firstly, well done. You've got to the point where real time matters. Real time these days is often required to compete. But if you go back 10 years, it was just a nice to have. So to compete 10 years ago, you needed just to be working. You needed to actually report. To compete now, it needs to work in real time because there's so many more efficiencies to be had, and there's so many more advantages to take.
Yeah. And I mean, you as a partner work together now for different projects, and you see also the whole market for these projects. So do you see that everybody is working on that, or a specific percentage of companies? Or do you see specific companies, like bigger companies, work with that? Do you have a personal opinion on that, how this market has grown the last years?
I'll take a stab at the bigger market. I think Stephan can talk to some more specifics on this one. So The general trend in the big side of things is that you used to be able to pay for MES systems, like the whole electronic, single pane of glass stuff. Hell, my first few jobs 15 years ago were exactly in it, right? We were building panes of glass on top of PLCs. It was really advanced at the time. But honestly, only the biggest people in the world could afford these, and they could make a significant improvement to their production lines or their monitoring systems with these kind of benefits. But when you went down the scale a touch, it didn't matter. These days, we've kind of democratized access. Uber and Netflix use Flink. I've been using Flink for many, many years, but it used to require 5 to 10 very skilled people to maintain and operate these clusters. Now it's available at the click of a button. So suddenly it's a thing which is actually accessible, and the access has become much easier, that it's no longer a thing you couldn't afford or had to build in from day one, but something you can now add.
Mm-hmm. Yeah. And I think we see this in several sectors. So I think there's no business where this could make no sense. Yeah. But I think also that sometimes the responsible people still have to understand the technology to see what capabilities come with dealing data or processing data in real time and which use cases and business value they can get out of it. So I think it's something obvious for the finance industry that we talked about with the credit card fraud. Mm-hmm. And I think it's very obvious, like with anomaly detection, predictive maintenance, things like this. But maybe this could also be interesting for public sector organizations, and deliver very new services to their members, clients, customers, whatever. Yeah.
And to elaborate on that exact one, think about using Google Maps for a second, right? I use it to get around cities and places I've never been. And in London, at least, the only reason this stuff works was because of what was the London Tourist Board became London and Partners. And they just basically opened all the APIs for all the transportation network in London to the public. You can just listen to these live feeds. And that meant that suddenly you could put predictive train times on various places. Like in Helsinki, there's literally an open MQTT feed for public transportation data. You can trail where every bus is in real time. And most of my demos with Apache Flink are based on one of these feeds because it's so powerful to be able to see this is where the vehicle is now, this is where it was 10 minutes ago, and this is its current state. And I have quite a background in logistics, and a lot of what we had to track was I have this vehicle in transit. It might be a boat, it might be a lorry, it might be a truck. And the difference, what is inside it, what has come off, what has come on, who owns it, is this continuous state updates. And the problem is, it's no longer that I just need to have a continuous stream. It's that I need to know the answer when I need it. So asynchronicity mandates real time. So I don't need to check what's in my vehicle until I absolutely need it. And that might be a customs check, but I must have no uncertainty at that point. I can't then wait. So the only way to do that is to gather in real time and then to read asynchronously.
Yeah. Okay. And maybe to add one question, because in the end, it's also an investment in technology. So the companies could also think like do it themselves with their internal teams, or they could also set it up with partners, for example, with you together. So what do you think makes Apache Flink and also in the constellation with you two special, where you say, hey, there are pitfalls you have to be aware of, and there are some best practices. So why should I choose Apache Flink, and why is, even though your constellation so interesting here? Can you talk a bit about this also?
Ben said before, Apache Flink is the de facto standard right now if we are talking about stream processing. If you start such a project, it's important to have both views. So the one side is the domain expertise, let's say in the manufacturing area, how the processes go, which kind of parameters are there, which sensors exist, and what do we really want to achieve. And on the other side, there is the whole technical part. How can I create an architecture that is really scalable, that reaches the performance that we need? Because latency can be a big issue. So if I detect, to stay with the credit card example, the event just a few minutes later, it might be too late, or in case of a machine that could get broken if the heat exceeds the threshold, for example. So then you need both sides. And I think what we as Steadforce can provide is the whole consulting, working together with the customer, and finally building the jobs. Mm-hmm. But on the other hand, I think Flink, of course, it's a very powerful, but also it can be a complex technology when it comes to operations, so day two operations, running it, so security questions and the whole maintenance thing. And there, I think it's very good to have a platform that is really production grade. And there, I think it comes to Ververica and to Ben.
Okay. Yeah. And Ben, now, I mean, there is, of course, also Apache Flink as an open source technology on the market. And then we have the commercial solution. So why do you think, or what are the key factors to work also together with you? Or maybe you could point out some things here.
So Ververica is probably one of the main maintainers of the open source. Like, we're built on that kind of firm foundation of open distributed technology, which allows kind of everyone at least to get started. Now, getting started with Apache Flink has, at least in the last couple of years, become a lot easier. You can just roll out the open source and it will work. But it's not really about just getting started. There's a very big difference between a prototype or a POC and an actual production system, particularly when you get to most IoT projects where the cost of failure and losing a record is no longer just, oh, the system's down, we can't sell something. It's instead, we might lose a few million in inventory and be down for weeks because something cooled too far, particularly in like a glass manufacturing plant or anything where like large robots are. So what really matters is surety. Like, it's the simple fact of, it'll be up tomorrow. If there's a security vulnerability, it'll get patched. That the people actually maintaining it and running it, as all software really does still need maintenance, right? These are complicated running machines. You don't run machines without experts. That it's going to have a service level agreement which is acceptable to you. You need to know that the people on the other side know their stuff, because the alternative is just very expensive. And this is the same reason why we all use the cloud these days. Data centers were never easy to do, right? Machines and hard disks and such are abstractions we don't need. It's the idea of, I just want to buy results, and buying results is nearly always cheaper than buying the bits that make the results.
And I'm not sure if you have a return on invest calculation on that, but is the investment for this streaming technology basically about like being what you're mentioning now, or is it like focus on time to market things? Do you have also insights about return of investment? Because I could imagine that a lot of companies think about that.
I'll give you two kind of perspectives on this. So the first perspective is what the cost of real time is. Now, there's a famous, perhaps apocryphal line from, I believe, Bezos about the idea of going 5 milliseconds slower costed $100,000 a month on the Amazon main page. And that was about 10 years ago. But though eBay have had similar findings with even higher numbers when their website slows down. So this is the fact of humans notice perceptual changes very easily. And that's on the kind of just human side. When you get to machines and tolerances, particularly when you start doing some of the finer, more careful manufacturing type usage, is a machine where even a single degree difference is quite significant, right? The ability to control the system to a finer level of degree means you can run it closer to the tolerances and run faster to the tolerances because you know you'll catch a problem faster. We don't do things at the max ever because we don't want to have the beats to be so close we'll never catch the problem. It's the same reason we don't actually use as much titanium as people think we do in airplanes, because of if a crack in titanium is not noticeable, whereas a crack in aluminium is. And if you see a crack in titanium, you're already gone versus a crack in aluminium. This is the idea of real time, means you can get closer to the problem before it actually becomes a problem. Now, the flip side of cost of ownership rather than cost of advantage is very clear. That's the easy bit. Let's say you're in Germany and a good senior engineer is 100,000 euros a year, and it takes 10 to run the platform and maintain it and run it. It's pretty easy to say that if you're paying less than $1 million for it hosted, it's pretty obvious you'll get a return on investment. And that's kind of the crudest metrics. It's only showing one side of the costs. In addition, particularly to what we do, is we don't quite run the normal version of Flink. We have optimized it heavily. It runs twice, if not faster, than the open source. So indeed, it normally takes even more to catch up. But you always have to look at the outcome more than the inputs. The inputs may change a lot, but particularly at large scale, it's all a bit lost in the wash. What matters is the fact that with better technology, you can just go faster. You can make better things, catch more errors, because the cost of failure is often far exceeds the upgrade you might get. So if you can just stop one industrial failure in the factory shutting down for 3 days, big deal.
Right, then you have the answer.
And I think not all the use cases are directly measurable in money. So for example, if I can improve my production process and get a higher quality of the end product out of it, this will help me to retain my customers, for example. But it's really hard to measure this in money.
Yes. Think about how many people you have to have on a shop floor if you can't check things in real time on a single pane of glass, right? Otherwise, you walk up to a machine and read a gauge. I've seen that and I have done that. It takes a lot of time and it's a bit soul destroying.
Yeah, exactly. And do you have any best practices on how to set up those projects the right way? I mean, you saw a lot of different projects now together with customers, but maybe also separated. What would be your best practice where you say, hey guys, when you want to set up a project like these, and we had some examples, what should I be aware of? Do you have any of these?
The number one thing to always remember with Flink is there's always more things you can do. I often joke that my job is to say yes, and I can say yes to almost anything of what Flink can do. But the real kind of first thing you should work out is, what are we trying to achieve? And more often than not, it's some quality goal or some monitoring goal or some responsive speed goal. So that all still comes back to data. So the first thing you should always do is model your data, right? You basically are building a data mesh, whether or not you wanted it. And these days, Apache Flink gives you some of the best tools out there to do this. So it's about model your data, be sure of what actually is real time, know where the data is coming from, and then just start by wiring it all up. Connect all the data sources you can, and then go from there. Build your downstream data products once you have the data in the system. Don't try and just build one thing and then see what else you can build. Connect it all first. Then you can easily build on what you have versus running out of something and having to recreate things downstream.
I would fully agree to this. So what we are doing is, for example, with our customers, we have so-called starter kit workshops. We have this for AI, cloud, or whatever, and also, of course, for stream processing things. And there our consultants go together with the customer, review the existing infrastructure, data sources, and so on, to have a good starting point to set up an architecture or an objective where we want to go. And then I think this is almost true for all kinds of software projects, that you start small, showing some value, of course. Yeah. And there we are back again. You can do this, of course, in the first steps with the open source version of Apache Flink. But then, and I think you should keep this in mind, that scaling and production will come. then it would be good to have a platform like the Ververica platform for the production.
Right. And when we talk about the platform, Ben, do you have a link where people could click on to have some more insights about that? Because I guess you have different solutions around that. So maybe I could put it also in the show notes to have some more information afterwards, because I guess there might be some people interested to say, hey, maybe I will have a look on your website and see what you're offering.
So the best place to get started is actually our cloud. So our cloud is very similar to our platform. It's called Ververica Cloud, or VVC as we often call it. It's a fully managed serverless version of Apache Flink with some upgrades as it runs on what we call the Vera engine. The reason I suggest this is it comes with $400 of credit just to get started, allowing you to connect up sources, model out SQL statements, and run Java and Python code on top of your data with relative ease. If you're getting started, that is possibly the best single place to start, simply because it requires nothing from you. The machines are running, the Kubernetes clusters are managed, and you just bring your code and run. Getting started on the open source is still normal. Like, you'd still develop your app on a standard Java or Python or SQL editor. But with SQL itself, just dump it into the online console and go from there. You can link any source you want. It comes with connectors. You can add additional connectors as you go. Even if you do end up needing to run on premises, we do provide a version on-prem, but getting started there doesn't make sense. It's always better to start with something managed so you have less questions.
Okay, that's cool. So I will put it in the show notes. And by the way, I just want to ask about the on-premise topic, because always the thing like customers are asking also, is that available on-premise? So you're mentioning you also do that, right?
This is actually where Stephan and I work together the most. We actually deploy a lot on premises because of these highly intensive data requirements and high privacy requirements. The curse of machines is they live a long time, and a lot of them were designed before cybersecurity was even a thing people considered. So they have to run on air-gapped networks, and the systems often have to be in the factories physically with them. Yeah. So we actually actively support most of our clients on premises. Like, we power some of the biggest banks in the world and also some of the larger manufacturers, specifically because we can run on premises with them.
I see. So, Stephan, these are your industry customers, or are these other customers who want to deploy their solutions on-premise here?
It's mostly in the industry area.
I see. Okay, cool. So, thanks a lot. I have so many more questions in mind, but I also want to pitch a bit the story and then give an overview of what Apache Flink is doing, what kind of use cases, and why you have to act on real-time data. So that was pretty clear, and thanks for that. And maybe the last question for today. I'm also looking into the future. I mean, we talk about like use cases which are deployed now and what customers are working on right now. So what do you see as the next big transformation here in industrial IoT data processing?
For me, it's going beyond just yourself. I think one of the biggest changes we're going to see going forward is the idea of everything going real time across a whole supply chain. Right now, real-time is little islands inside companies where it takes you might be real-time in one factory or maybe two or three, but it's very rare you're real-time across organizations. The big thing I can see happening is that I'll have a real-time feed from the factory that produces the things upstream of my factory. Or like in the logistics space, it's the port authority will give me a real-time feed of which berth ships should be landing in and which customs inspection warehouse is going at what speed, meaning that everything can be made real time rather than just the middle piece, a sharing of the data.
Okay, that's cool.
And I would come from a little bit more technical perspective. I think stream processing will get more accessible. So we didn't talk today about Flink SQL, but in fact, that's the possibility to create a Flink job just using standard SQL. And that, of course, is much easier than programming it like in Java or something like that. And this can even do people which are not explicit software engineers, but have, let's say, the knowledge about databases. And I think this trend will go further and
Okay, so thanks for your insights here. And also thanks for your time. I found it very interesting to learn from really concrete practical use cases how the technology is used and how also your partnership and what's the offering behind that. So that's pretty cool. And first of all, thanks for your time. Thanks that you've been here in the podcast. And so last words to you.
So thanks, Madeleine, for having us. I'm really looking forward also with Ben for the next projects we can do together and problems we can solve. And of course, if anyone has questions, feel free to reach out and let's talk about how we can make software solutions more real-time.
Same again from me. It's great to be here. It's great to kind of explore these kind of use cases and kind of show a bit what happens. We have a bad habit, particularly in the kind of industrial IoT space, of living behind very closed doors. And it's good to kind of talk more about what is possible, and particularly tools which are open.
Right. So last word, I will also put your contact in the show notes that you could connect with Stephan and Ben now. So please feel free to get in touch and have a great rest of the week. Bye-bye.
Bye.